So this panel is called Advancing Cameras for Cinema, and no matter what gets said at this panel, it is a magnificent panel just for having these people on the stage. Taka Yamashita, as I mentioned, from NHK, part of the group that came up with that 8K, 120 frame per second camera. Peter Senton from Grass Valley 5 years ago at this very summit showed pictures of a 10 million to 1 contrast ratio and high dynamic range, and I think he's going to show some stuff even better in a moment. Siegfried Fössl from the Fraunhofer Institute has been working on such things as masked sensors and light field capture, and he'll talk about some of that stuff. And then last but certainly not least, Eric Fossum, who's currently at the Thayer School of Engineering at Dartmouth, is the inventor of the CMOS sensor. So those of you who have cameras in your cell phones or are using your point and shoots, whatever, he's the guy who's responsible for it. And virtually every camera you're going to see in the exhibit hall. So just a quick introduction here. Where are we going? Higher resolution and frame rate, higher dynamic range, more flexibility in post, lower cost, who knows what else, and you'll hear some who knows in this presentation. More pixels per second. Let's take 1080 at 24 frames per second, 1080p at 24 frames per second. If you have a single sensor and it's got a Bayer color filter on it, then you're talking roughly 50 million giga color subpixels per second. I'm calling it color pixels per second because I didn't have room to stick in the sub. If it's a prism camera with 3 chips, then you're talking 150 million. At the Super Bowl, the 4A FT1 was 4K and goes up to about 900 frames per second. That's 8 giga color subpixels per second. The NHK 3-chip 120 frame per second, that's 12 giga color subpixels per second. Now you could go back up to that 1080p camera and mask its sensor and potentially get higher resolution just from the masking. So that's one interesting thing. High dynamic range. These are the pictures that Peter Senton showed here 5 years ago. The only illumination of that picture on the right is coming from the lamp that is aimed directly at the lens of the camera. And if you look at the picture on the left, you can see all of the individual coils of tungsten in the lamp that's illuminated. Plus, you can see every chip on the chip chart. You'll see some new stuff on that in a moment. Cost and flexibility. At the moment, lenses cost more than cameras. We've been using lateral chromatic aberration correction for some time, but can we get to other lens corrections? Blur deconvolution for focus. The camera I'm showing is the Sony F5, list price a little less than $20,000. The lens I'm showing below it that you might want to stick on that camera is a new Fujinon Premier PL 4K Plus. The list price on that is $100,000. So the lens is 5 times the cost of the camera. And then we have light field capture, where you can change focus in post. You can change the camera's position in post. You can derive depth information from a single lens.